Your VPN worked fine through 2024. You used it every day, it connected, it held. Then, sometime in the first months of 2026, it just stopped. Telegram opens, it spins, it fails. You cycle to a new server, same thing. This isn't your app misbehaving and it isn't a bad week on the line. The Great Firewall learned what your circumvention tool looks like and it now kills the handshake before it finishes. This video is about what actually still works. Telegram has been blocked in China since 2015, so that part is old news. What changed heading into 2026 is the depth of enforcement. The Cyberspace Administration finished rolling out a new generation of deep packet inspection across China Telecom, China Unicom, and China Mobile in late 2025. The three state carriers now share threat intelligence in near real time. So when a new circumvention signature gets identified on one network, it propagates to all three within hours instead of weeks. If you're an expat in Shanghai, a journalist in Beijing, or an operator with Chinese counterparties, this is the gap you fell into. Here's the plan. First, exactly why your VPN keeps dying. Because there are four separate mechanisms and most people only understand one of them. Then the three approaches that still survive, ranked honestly by how long they last. And then the setup I run, a managed phone outside the wall, including the real trade-off so you can decide if it fits. Start with the first mechanism, deep packet inspection on the carrier backbone. China state carriers run stateful DPI at every major peering point. And this isn't shallow metadata inspection. It's full stream reconstruction, protocol fingerprinting, and behavioral analysis. A WireGuard tunnel doesn't expose its content at layer 2, but the traffic patterns, the packet timing, and the handshake sequence are all detectable without reading a single byte of what you sent. The machine doesn't need to know what you're saying, it only needs to know you're using a tunnel. And it's good at that now. The Censored Planet team and the Geneva project at the University of Maryland documented in late 2025 that China's DPI classifies obfuscated traffic with over 90% accuracy within the first 30 packets of a new session. 30 packets. That's the first fraction of a second. You're not waiting for the system to notice you over minutes of use. It has already decided before your first message sends, and that number keeps climbing as the classifier trains on more attempts. The second mechanism is IP block lists that update continuously. Every major commercial VPN has had its server IPs indexed. NordVPN, ExpressVPN, Surfshark, Molvad, all of them. It isn't mainly a secret government list, though that exists too. It's that these providers operate at scale, so the IPs show up in public APIs, in routing data, in pattern analysis. The clearinghouse pushes updates to all three carriers daily. When your app cycles to a new server, there's a real chance that IP was already on the list before you ever tried it. Scale is the enemy of stealth, and that's why residential proxy pools and data center rotation services get chewed through by the exact same logic. The third mechanism is SNI inspection and TLS fingerprinting. Even over TLS, the server name indication field in the handshake reveals the destination. The firewall has done SNI blocking for years, but the 2025 upgrade extended it to encrypted client hello detection. And here's the part people miss. Even if the SNI isn't readable, the pattern of which IPs your client contacts, in what order, at what intervals, is itself a classifier input. You're not fighting a policy rule you can route around, you're fighting a machine learning system trained on years of circumvention attempts. The fourth one is the blunt layer sitting on top, DNS poisoning and blocking at the app layer. Telegram's domain names are poisoned at every authoritative resolver inside China. A fresh client doing a normal lookup just gets garbage back. So now you can see the real shape of the problem. DPI, IP block lists, SNI inspection, and DNS poisoning combine into a wall with 4 layers, and no single tool handles all 4 cleanly. That's the whole reason single tool answers keep failing. You fix one layer and the next one catches you. So what survives? 3 approaches, and I'm going to rank them by survival rate honestly, including the one that's fading. First, mtproto proxies and Telegram's own native obfuscation. Telegram randomizes its byte distribution to avoid protocol fingerprinting, and in 2022 and 2023 that worked reasonably well. In 2026 it does not. Dedicated mtproto proxies with Chinese user bases get flagged within days of going public. Private proxies shared inside a small trusted circle last longer, but finding and keeping access to one is its own ongoing project. If you've got a contact outside China running a dedicated server just for you, it can work. If you're pulling from public lists, plan for constant breakage and weekend troubleshooting. Survival rate here is low and declining. Second, mobile SOCKS 5 routing through a neutral jurisdiction. This is a meaningful step up. Instead of routing through a data center VPN endpoint, you route through a SOCKS 5 proxy sitting on a real residential or mobile IP in a country the firewall doesn't aggressively target. The phrase that matters is neutral jurisdiction. A residential IP in Singapore on a Singtel or StarHub SIM doesn't look like a VPN endpoint because it isn't one, it's a phone. The traffic profile looks like a phone user because that's literally what it is. The firewall's risk calculus includes diplomatic cost, and blocking whole Singapore carrier ranges would hit legitimate business traffic in ways Beijing would notice. Survival rate is medium. The catch is that it needs real setup and the underlying phone has to stay online. And before you trust any SOCKS 5 someone sells you, verify it. From a terminal, you run a curl through the proxy and look at what comes back. You want the org field showing Singtel, M1, StarHub, or Vivify, and the country showing SG. If you see a data center as AN or any other country, the proxy isn't what was advertised, and you walk away. Use the SOCKS 5H scheme, not plain SOCKS 5, because SOCKS 5H forces DNS resolution through the proxy itself and stops your real resolver from leaking the lookup. Third, the managed cloud phone outside the wall. This is what Telegram Vault is built around, and it's the highest reliability option I've watched hold up in practice. A physical Android phone in Singapore running one Telegram session on a real Singapore carrier SIM that you reach through your browser from wherever you are. Nothing that looks like Telegram traffic ever leaves your machine in Shanghai. From the network's point of view, you're just running what looks like a remote screen session. The phone doesn't go offline when your apartment Wi-Fi drops. It doesn't get swept up by IP block lists because carrier IP ranges aren't on those lists. And you don't manage the hardware, the SIM, or the session continuity. Survival rate is high, operational overhead is the lowest of the three. Let me make the Singapore argument properly because it's the whole reason this works. The firewall is designed to block what the Chinese government wants blocked. It is not designed to block Singapore. Singapore is China's largest foreign investment partner by several measures. It hosts regional headquarters for Chinese state enterprises, and both sides keep pragmatic relations that neither wants disrupted over routing policy. Blocking Singtel or StarHub ranges wholesale would create collateral damage for too many legitimate commercial connections. A dedicated phone on one of those carrier ranges sits in a political and technical blind spot that data center AppES, US residential AppES, and known VPN addresses simply do not occupy. This doesn't make it invisible forever, and I won't pretend it does. If a given IP starts generating traffic that looks like a pure Telegram relay at scale, that IP can get flagged. But a phone doing what phones do, with one persistent session on it, runs low signal. The session looks like a regular Singapore user who keeps Telegram open all day, because that is exactly what it is. One phone, one IP, one session is genuinely harder to detect than shared residential pool rotation, where the same address suddenly gets hammered by 100 different patterns. The latency trade-off is real, and I want you going in with the right expectations. Singapore to Beijing adds roughly 60 to 90 milliseconds of round-trip latency depending on your ISP inside China and routing at the moment. For text messaging and file transfers, you won't feel it because Telegram is asynchronous. For voice calls and video calls inside Telegram, you will notice it. Voice messages, the push-to-talk kind, work fine. Group voice calls will have a perceptible lag. If you run a channel, a business group, or async coordinations, that latency is irrelevant. If your primary use is live audio calls, manage your expectations. Now the setup, because the flow is simpler than people expect. You get access to a cloud phone, open the browser interface, and you're looking at a real Android screen. You open Telegram on that phone, enter your own number, and Telegram sends the OTP to your number the normal way. You type it in. We never see the OT app, we never ask for it, we don't store credentials. From that point, your session lives on the cloud phone around the clock. You close your browser and the session keeps running. That's the model where you bring your own number, and it means you keep your existing account with all its contacts and channel history. Once the session is on Singapore hardware, harden it and do this before anything else. Two-step verification is not optional. Go to Settings, Privacy and Security, Two-step verification, and set a strong password. So even if someone intercepts an OTP, they can't complete a login. Then turn Contact Sync off under Privacy and Security, because the address book sync feature is a full metadata record of everyone you know, and from inside China that risk is not theoretical. And audit your active sessions regularly. The cloud phone shows as one session. If you also run Telegram on your local device, that's a second. 2 sessions is expected, 3 or more warrants investigation, and you terminate anything you don't recognize on site. Here's the advantage nobody mentions until they've lived it. Your local internet in China will drop. It throttles in the evenings, it goes dark on politically sensitive days. The cloud phone in Singapore doesn't see any of that. Messages keep arriving, groups keep running, channels keep updating. When your connection comes back, you open the browser and see a phone that has been running the entire time. Your session didn't time out, your messages didn't queue up in a failed send state. That uptime is the core thing China users are actually paying for, and is the part that's hard to appreciate until the first time your line dies in the middle of the week and nothing you care about misses a beat. So if you've burned through 3 VPNs this year and you're tired of the weekend troubleshooting, this is what Telegram Vault does. A real Singapore mobile IP on Singtel, M1, StarHub or Vivify, a real Samsung handset, your own number, and a managed session that just stays up. You don't touch the hardware or the SIM, we accept card and we accept crypto like STT and BTC for customers whose Chinese cards get declined on international transactions. Pricing starts at $99 a month for 1 account and scales to $8.99 a month for 15. Right now it's concierge onboarding only, which means a human reviews your request, walks you through setup, and runs a connectivity check for your specific location before you go live, because configuration errors cost more when you're inside the wall. You can start a trial at Telegram Vault. The link is in the description, and use code TGYT for 30% off your first month. Verified China customers get priority onboarding. If this saved you a weekend of cycling through dead servers, subscribe because the next video covers Telegram in Iran, where the DPI system is tuned even harder against the fake task technique most proxies use, and the fix shifts accordingly. Different countries, same layered problem, slightly different answer. Thanks for watching, and I'll see you in the next one.